Hi, in this tutorial, we'll go through the steps of making an Istio virtual surface accessible to clients outside and inside a surface mesh. And these are done in a united framework. First, we are given an Istio virtual surface. Again, it's part of the book info sample apps that comes with nearly every Istio release. Such a virtual surface defines a set of traffic rules for client requests to be redirected to the target Kubernetes services and workloads based on customized criteria, like for the purpose of content switching, load balancing, load distribution, canary deployment, and others. The virtual surface is accessible to clients outside the surface mesh through an Istio ingress gateway. And in the meantime, clients inside the surface mesh will use the local proxy sidecars spreading throughout to reach the virtual surface. And in doing so, they will bypass any Istio ingress gateway altogether. So this is a Chiari graph showing the book info sample surfaces at work based on the given topology. In the default setup, the virtual surface is mounted on an Istio ingress gateway, and the virtual surface applies to the target Kubernetes service product page. And you may also be aware that to any host that resolve to the external or custom IP of the Istio ingress gateway can be used to access the virtual surface. So we start with our study of access outside surface mesh. The main idea is that the virtual surface is mounted on an Istio ingress gateway. So to begin with, the external IP of the ingress gateway is to be mapped to an appropriate FQDN hostname through DNS or local host tables for any clients outside the surface mesh. And then this FQDN hostname will be included in the virtual surface spec host list. So in this tutorial, one of the Kubernetes nodes that is the control plane will stage as a client outside the surface mesh so that we can run a curl request to call the book info virtual surface. So let's get to our hands-on session now. So first, as I mentioned, I will add the external IP of the ingress gateway and its mappings to an appropriate host name to the local host table. Let me recap the external IP of the ingress gateway. And that's the external IP. We add it to the host tables. Let me give it a name, my gateway external account. And there's a FQDN destination. So adding the mappings to the local host table is just a quick way of achieving this name resolution effect. In fact, if you have an external DNS available, you can add the mappings to the DNS. So after we take care of the name resolution part, and then we will go on to add the relevant settings to the virtual service CRD manifest. So first of all, let's add some filtering controls to the gateway's host list. We don't want to leave it wide open by specifying the single asterisk character. We don't want to leave it as anything goes. So we restrict the gateway host names to those with this domain suffix. And after that, we add the host names. We input just before in the host table. And that is my gateway.external.com. Yeah, we are done with the manifest, and then we apply the manifest to get the virtual surface and gateway. Right. Let's check virtual surface. Yep, that's the one. That's the gateway name, and the host part is set to this FQDN, as we have done on the manifest. So let's run the curl command on the control plane as a client outside the surface mesh to call the virtual surface. Great. So we've got the result we expect. So we are done with the part for access outside the surface mesh. So now we can move on to access inside surface mesh. So what do we mean by a client accessing the virtual surface inside the surface mesh? That means requests are initiated by client pods that belongs to the same namespace as the surface mesh. And in this case, it is the default namespace. And in doing so, each client pod also runs in conjunction with a proxy sidecar. And in the tutorial, we use the official curled Docker image to stage a client pod to initiate access or to make request for the virtual surface. And note that there are two options to mount a virtual surface inside the surface mesh without touching to any ingress gateway. First is based on a portless Kubernetes surface. And the second option, similarly, is based on an endpointless Istio surface entry. And we will go through them one by one. So here is the portless Kubernetes surface. It is a normal Kubernetes surface that is created without setting any ports to address or to cover. And after we create such a surface, and then we need to make a couple of corresponding changes to the virtual surface CRD manifest. First, the reserved word mesh should be included in the virtual surface spec gateways list. So this is the first change we need to make. And the second change is that we also need to include the portless surface named in the spec whole list of the virtual surface. After we restart the book info virtual surface, and then we run the curl command on the curl box to test our access to the virtual surface inside the surface mesh from a portless surface. Let's move on to the tutorial hands-on lab for this part. So first we run the curl box pod as a client inside the surface mesh. Yep. So the curl box pod is running with two containers. One is the curl box container, and the other is the sidecar. Is the proxy sidecar. So we get the curl box up and running, and then we have to modify our booked info gateway and add the portless surface to the manifest. First, we delete the existing gateway and the virtual surface. And we added the CRD manifest for the virtual surface. First, we add the portless surface to the manifest. Then we call the surface portless and specify the name and the port. So note that we don't include any selector attribute to do anything with the port. And after we add the surface definition, we also add the surface name to the host part of the virtual surface. Okay. Another thing we need to do is to add the mesh keyword or reserved word to the gateways list. This indicates our scheme of getting the virtual surface to be accessed through ingress gateway and internal mesh in the form of proxy sidecar. And there you go. So we have done the gateway and virtual surface configuration. We apply the CRD manifest. Let's check out our newly created virtual surface, or more precisely, newly enhanced virtual surface. Yep. So you list everything we expect. Gateways have two parts, the ingress gateway and the mesh. And also for the host part, we have the mygatewayexternal.com that we added earlier, and then the portless surface. Good. So we get everything ready, and we should be able to test out the curl command that is to be executed on the curl box, on the curl port. Yes, one more. Yeah, we can also check one more thing. When you list the Kubernetes surface, and you'll find that the port list shows up here with the custom IP. Yes, we execute the curl command on the curl box. So first of all, we use the portless host name for the host part of the URL. So we've got the result we want. Next, we use the FQDN named of the portless surface. Since it belongs to the default namespace, so we add the domain suffix of the default namespace to the portless host name. So it's default and then SBC. That's that should be this one. Good. We get the result we expect. So we have done the portless surface for access inside the surface mesh. So we can move on to the second options for access out inside the surface mesh. So it's the endpointless surface entry. So what is an endpointless surface entry? It's an Istio surface entry that's created but without any endpoints specified, similar to a portless surface. So when creating the endpoint, the endpointless surface entry, or when creating such a surface entry, there are a couple of settings that we need to provide for the surface entry CRD manifest. The first one is that we provide the endpointless surface named as a as an entry for the surface entry specs host list. So the endless surface name is included in the surface entry spec host list. That is the first bit of the settings. And the second bit of the settings is that we choose a static IP and include it in the spec addresses list of the surface entry. So the surface name and the static IP are two particular settings that we need to provide for the surface entry CRD manifest. Another part is that we have to use the reserved word mesh internal to be entered for the spec location field of the surface entry. So these are three settings that we need to provide for the endpointless surface entry. And then we also need to make a corresponding change to the virtual surface CRD manifest, and that is to include the endpointless host name in the spec host list of the virtual surface. So as you may recall, so at the end, the virtual surface spec host list will consist of first the mygateway.external.com, then the portless surface name, and the third one is the endpointless host name. So these three items will be included in the virtual surface spec host list. Also, a notable task to do for the endpointless surface entry is to add a new host record manually to the Kubernetes core DNS to map the chosen static IP we mentioned earlier to the FQDN host name of the endpointless surface. So just pay attention to this part. We need to do it manually for this for the endpointless surface entry to allow its access to the virtual surface. So let's move on to the hands-on lab for this part. So first of all, as we need to assign a designated static IP to the service entry host. So it's better for us to retrieve or to pull out the service cluster IP range that is used to configure the Kubernetes cluster. So we use this command to get the service cluster IP range. And so there you go. And this 1096 IP address block is the one to be used. Is the one where we choose our IP from to assigned to the to the to the Kubernetes service cluster. So in this tutorial, we will use the IP address 10.96.25.1. So you will see how I do the mappings shortly by modifying the core DNS or by adding the host record to the core DNS. So now, after confirming the service cluster IP range, and then we add the host record to the core DNS. Yeah. We will add the host record here. So this is the chosen static IP, and here is the endpoint list host name that we will use for our endpoint list service entry. And this is the FQDN. This is the FQDN DN name. This is the simple host name. After we modify the core DNS configuration, our way to restart the core DNS, we just need to remove the existing core DNS, and then the core DNS will start in a predefined number of replicas automatically. So these are the two that we are going to delete, so that a new core DNS, so that new core DNS copies will start with the new configuration. Yeah. We have removed the existing core DNS. Let me check whether we have some new copies of core DNS brought up. Yep, we've got the new ones. And presumably, they will also take the new host mappings into account. Yeah, after that, we'll do some modifications to the virtual service CRD manifest. We will add our service entry here. Yeah, this is the new service entry we add to the CRD manifest. Since we leave out the endpoint part, so it means that we don't need to add an awful lot of substance or directives to the service entry CLD manifest. So basically, it's only concerned about its customer-facing appearance, like the host name and the address. Yeah. So you can see we set the name to endpoint list, and the host set to be the same as the name of the service entry, and this is the IP address um, we chose before. Actually, we've already added the IP address and its host maps to the core DNS, and also we set the location for the for the for the service entry to match internal. Good. So we are done with the service entry um, for the with the endpoint service entry. And here, like I mentioned before, I get one more items is to be added to the host list of the virtual service. And you guess it, this is the endpoint list. So there you go. We are done with the CLD manifest for the virtual service entry, for the virtual service and the service entry. And now we apply the manifest to rebuild the virtual service and also build a new service entry as well. Let's check the yes, sorry. Let's check the virtual service. Yep. The new host destination endpoint list has already registered with the virtual service. And if you are curious, you can when you list the Kubernetes service, you don't see anything related to the endpoint list. It is because the endpoint list we don't involve direct creation of a Kubernetes service when we create this service, this Istio service entry. It does not involve any direct creation of any Kubernetes service. So that's why you won't see anything related to endpoint list show up in the listing of the guest service of the kube control guest service command. But the effect is already should be underweight when we use the endpoint list to access the virtual surface, and that's what we are going to do now to test our access to the virtual surface using the endpoint list host name. Bear in mind that we need to specify the full FQDN name for the endpoint list host in the host part of the request URL. And that is the only acceptable form for the host part of the request URL. So typo. Good, there you go. Yep. So we've got the result that we expect. so that we can dig deep into the routing situation of the curl port proxy sidecar, and to see what the workings of the routes are. So in this regard, we used the Istio control command with the proxy config flag or option. We output it to a file so that we can explore the file. Yeah. So let's look up for the portless surface part. Yep. And there you go. And this is the route we are looking for. portless.default.svc.custard.local:80. You can see definitely is engaged to perform the required traffic rule. So you can see the acceptable host part of an URL include this domain's designation or this domain's titles. So you can have the FQDN name of portless, a single portless host name, and even some portless with some substring of the FQDN, or we better put it the left substring of the FQDN, like this one. And you can also specify the cluster IP of portless in the host part of the URL to call the service. So that's the portless part. And then let me search or look up the endpointless part. Yes, this route is also instrumental in implementing the traffic rule. So you can see only one host name form is accepted for the host part of the URL, and this is the FQDN host name of endpoint list, or we can put it as the endpoint list with the domain suffix of the default namespace appended, and this is the acceptable host name is restricted only to this FQDN string. So that's why we need to specify the FQDN of the FQDN form of the endpoint list host name in the host part of the URL to call the virtual service. So there you go. That's about it for our tutorial of setting combo access to a virtual service for clients outside and inside a service mesh. And here are the key takeaway points from the result we obtained in this tutorial. So first, for access outside the outside the service mesh. So the virtual service spec host need to include the FQDN string that resolve to the external IP of the ingress gateway. And as I have shown in the tutorial, you can implement the name resolution by using localhost table, or better still, if you have an external DNS, that's modified your external DNS and add the FQDN, add the mappings between the external IP and your chosen FQDN. And after that, you specified you specify the virtual service spec host as your designated FQDN, and then you use this FQDN to enter the host part of your URL request and call the virtual service. So this is the part on access outside service mesh. So for access inside the service mesh, there are two ways of doing the access. First of all, you create a portless service that is without specifying any labeled ports to select for the service. You specify such a service, you create such a portless service, and then you set or you include the service name in the virtual service spec host list. And after that, the acceptable URL host will include the portless service name with or without domain suffixes of the default namespace appended. So that is the second. That is the first way of doing access inside service mesh. And the second way, for the second way of doing access inside service mesh, you create an Istio endpoint and service entry and specified the service entry host to a designated host name, and a important part of the task is to modify the core DNS of the Kubernetes cluster to map your chosen service entry host name to a designated static IP. And when you do the mapping, you will include the service entry host name, the FQDN formed of that host name in the map to the chosen IP. And after that, when you specified the host part of your URL request, you are only allowed to enter the endpointless service entry host name with the full domain suffix of the default namespace appended in the host part of the request URL. So it means that the host part of the request URL is limited only to this endpointless service entry host name with the full domain suffix of the default namespace appended. Good. So that's about it for this tutorial, and I hope you enjoy the show, and yep. See you next time. Bye bye.